Good evening, everyone. Keep joining. Good evening, my dear students. Please keep joining as soon as possible. Very good evening to my dear students. Please join as soon as possible. Please join. Good evening to dear students. Please join as soon as possible. Those are present in the class, please mention your name. Those are present in the class, please mention your name. Those are present in the class, please mention your name. Very good evening to my dear students. Please mention your name on the chat box. Okay, very good evening, Shravani. Very good evening, Ankit. Those are present in the class, please mention your name. So, shall I start the class? Okay. Hi, Sumit. How are you? Everything is fine? Okay. Okay, so let's start the today class. Okay, without any ado. So, already we have done the two class regarding different type of questions. We have seen different type of satellite remote sensing, their applications, some numerical from GPS, GIS, engineering, mathematics. Okay. So before start the video, to mark your attendance, please hit the like button on the chat box. Okay. So all good. Okay. So my audio and video is clear to everyone. My audio and video is clear to everyone. Sri Brahman, Ankit Ghosh, Sumit, those are sitting in the class. My video is my video and audio is clear to everyone. Sri Brahman, may I know your name? Okay. So, this is your first question about today class. Okay. So now question is, what is the primary purpose of list square adjustment in surveying measurement. Okay, what is the primary purpose of least square adjustment in the surveying measurement? Option A, minimizing systematic errors. Option B, maximizing random errors. Option C, ignoring errors simplicity. D, balancing measurement uncertainties. Okay, Tapam, option D. Ankit, option D. Okay, अच्छा, Sri, option D. What is the primary purpose of least square adjustment? Okay, the answer is option A. Okay, minimizing the systematic error, not balancing measurement uncertainties. Okay, why option U D? Everyone is wrong. Okay, Arvind is right. Minimizing systematic error. Okay, the option is minimizing systematic errors. Why? Now, least square adjustment is a statistical method used in surveying to minimize the sum of the square of the residuals, which are the difference between observed and calculated value. It primarily aims at balancing measurement uncertainties by giving more weight to accurate observation and less weight to less accurate ones. Okay. So, do you know what is the observed value and calculated value? Suppose this is x, okay, and this is observed value, and this is calculate value. Okay, suppose whenever we are going to IDW, okay, inverse distance weighted. So that time what happens? Initially we have taken, suppose 100 points. Okay, initially we have taken 100 points. Before the 100 points we have taken only 70% of the point. Okay, so through the 70% we have generated a raster. Okay, raster data to the 70%, and rest of the amount 30% we need to validate the raster. Okay, so suppose here generated raster observed value is 12. Okay, but true value is 12. तो 30% डेटा था उसका ट्रू वैल्यू इज ऑब्जर्व वैल्यू 12 बट कैलकुलेट इज समथिंग 10. Okay, then 13 and calculate value may be 15. Okay, then observed value may be 18, may be 16. So these observed value come from where? Now rest of 30%. Okay, so through the 70% data, suppose this is a satellite image. Okay, you know the this pixel value, this pixel value, this pixel value, and this pixel value. So through this pixel value we have created a full raster in the DEM. Okay, so these value are observed value or true value. So in this case, now observed value minus calculated value, that is the residual value. Okay, now sum of the square of the least square adjustment statistical method used the serving to minimize the sum of square of the residual. Okay, which are the difference between observed and calculate value. It is clear to everyone? Those are sitting in the class. It is clear to everyone? Arvind, Sri, Ankit, Sapnam, Sumit. Shall I go for next question? Please go fast, go fast. We need to cover more question, okay? So try to answer fastly. Okay. So next question is, calculate the spectral resolution of a remote sensing sensor if it captures the electromagnetic waves ranging from 400 to 700 nanometers. Answer should be micrometer up to 3 decimal. Okay. So calculate the answer. Calculate the spectral resolution of a remote sensing sensor if it captures the electromagnetic waves from 400 to 700 nanometers. Answer should be micrometer up to 3 decimal. Okay. Try to answer everyone. What you need to find? The spectral resolution of a remote sensing sensor. Okay, not spatial. Arvind, Tapam, Sumit, Ankit, Sri. Arvind, Typer, are you trying, guys, or shall I go for calculation? Anyone trying the try to give the answer, or shall I go for answer? Calculate the spectral resolution of a remote sensing sensor. It captures the electromagnetic wave ranges from 400 nanometer to 700 nanometer. Answer should be micrometer up to 3 decimal. Numeric assessment test. Question mark is 2. Okay. Anyone trying to solve this question? Anyone? Okay. So, the spectral resolution of a remote sensing sensor refers to the ranges of wavelengths it can capture. It is calculated as the difference between the maximum and minimum wavelengths. Okay. So, spectral resolution equal to maximum wavelength and minimum wavelength. So, here spectral resolution is maximum 700 nanometer and lower is 400 nanometer. So, difference is 300 nanometer. Okay. So, what do you do in spectral resolution? Suppose when you are talking about the spectral resolution, so number of bands. Okay. If suppose I am taking a panchromatic bands. Okay. The ranges between 700 nanometer to 400 nanometer. So, what is the bandwidth? 300 nanometer. Okay. This is the spectral band or bandwidth we can say, or band difference, and the answer should be in nanometer. So, 1 micrometer equal to 1000 nanometer. Okay. So, what happened? Now answer should be in micrometer. So 300 nanometer divided by 100, 1000, okay, 1000 nanometer. So 3 divided by 10 equal to how much? Basically you need to convert nanometer to micrometer. Okay, 1 micrometer equal to 1000 nanometer. Okay, so you can easily convert about this. It is clear to everyone? It is clear to everyone? Arvind, Ankit, Sapnam, Sumit, Sri, those are sitting in the class. It is clear to everyone? Up to 3 decimal, Arvind, you have remember. Up to 3 decimal means after you need to 3, okay, 3 point. So 3 divided by 10 equal to yes. Whenever the answer asking up to 3 decimal, so you need to put 0.300, okay. If mention somewhere up to 2 decimal, up to 3 decimal, if suppose somewhere 0.367 asking about up to 2 decimal, that times you need to convert 0.37. So ये value कितना है, greater than 5, so 6 becomes 7. This is the answer whenever asking 0.327. It is clear to everyone? Sri, are you there? Then go to next question. Calculate the scale distribution factor for a Lambert conformal conic map projection with a scale of 0.9. Calculate the scale distribution factor for a Lambert conformal conic map projection with a scale factor 0.9. Anyone trying to giving this answer? Calculate the scale distribution factor for a Lambert conformal conic map projection with a scale factor 0.9, or shall I do it? Those are sitting in the class. क्या आप लोग कोई ट्राई कर रहे हो और क्या मैं कर दूं? Arvind, are you trying to solve this question? Ankit, Tapam, Sri. Anyone? Those are sitting in the class. The scale distribution factor lambda for a Lambert conformal conic position can be calculated using this formula. Okay. So here scale distribution or theta equal to 1 divided by scale factor, okay, 0.9. So 1 divided by 0.9 equal to 1.4 times 1. It is clear, just remember that. 1 divided by scale factor, okay, the scale distribution factor for a Lambert conformal conic position can be calculated using this formula. 1 divided by scale factor, okay. If scale factor is 2.5, then 1 divided by 2.5. If scale factor is 1.5, then 1 divided by 1.5, okay. It is clear to everyone? Arvind, Ankit, Sahi, Tarun, welcome. I think you are the new in this MCQ series. Tarun, are you the newcomer in this MCQ series? It is clear, everyone? Just remember the 1 divided by scale factor, okay. 1 divided by scale factor. रट लेना, ठीक है. The scale distribution for a Lambert conformal conical position can be calculated using this formula. So calculate the spatial index size for a GIS database covering a area of 500 square kilometer with a grid size of 10 meter. Calculate the spatial index size for a GIS database covering a area of 500 square kilometers, okay, with grid size of 10 meters. Calculate the spatial index size for a GIS database, okay, covering a area of 500 square kilometer with a grid size of 10 meters. Okay, here is the two different units. One is square kilometer, another is 10 meters. Arvind, are you trying to solve this question? Ankit, Sapam, anyone? Calculate the spatial index size for a GIS database. Spatial index means? No. Spatial index size means the total number of pixel, okay. Total number of pixel, okay. So total number of pixel. Calculate the spatial index size for a GIS database covering a area of 500 square kilometer with a grid size of 10 meter. Shall I go for calculation? The spatial index size or n can be calculated using this formula, okay. N equal to total area by grid size. So here total area is 500 kilometer square, okay, and pixel size is, grid size is what? 10 meter. So here you can see it is given a area of a, suppose this is a total area, okay. Total area equal to how much? 500 square kilometer, okay. And grid size means suppose is a smaller pixel of this area, grid size, the one side is 10 meter, the grid size, okay, here cannot mention the square, okay, grid size is meter, 10 meter, 10 meter, okay, so you need to at first calculate the area of this pixel. So 10 into 10 equal to how much? 100 square meter, okay. So suppose one pixel is cover 100 square meter and your total area is 500 square kilometer. So number of pixel, how much number of pixel is required to cover all the image, okay. So anyone know the 1 square kilometer equal to how much square meter? Anyone know? So here at first we need to convert 500 kilometer square divided by 100 square meter, okay. So here smallest in is square meter and here is kilometer square. So you need to convert this in the smallest unit, okay, in meter square, or you need to convert 100 square meter to square kilometer, okay. It is better to in the smallest unit. So 1 square kilometer equal to 1 into 10 to the power 7 square meter, okay. That means 1 2 3 4 5 6 7, okay, 1000. So how much? It is about 1 crore square meter. So what happened? Now 500 into 1 2 3 4 5 6 6 7 divided by 100 स्क्वायर मीटर था, यहाँ पे स्क्वायर मीटर था, स्क्वायर मीटर कट गया, ठीक है। तो यहाँ पे 20 कट गया, सो इक्वल टू हाउ मच? ना 5 इंटू 1 2 3 4 5 7 10 to the power 7 पिक्सल चाहिए, ओके। 10 to the power 7 इक्वल टू ना 1 2 3 4 5 6 7, ओके। तो टोटल इतना पिक्सल चाहिए, इतना ना 5 करोड़। हाउ 10 to the power 6 तपम, हाउ 10 to the power 6? Tell me 1 square kilometer equal to how much? Please anyone type your chat box and try to answer. Okay, okay, okay. Yes, 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 yes. The answer is 5 into 10 to the power 6. Yes, yes. 1 square kilometer equal to 10 to the power 6 square meter. Yes, yes, yes. Okay. So at first you need to convert 500 square kilometer to square meter. Okay, and divided by area 100 square meter. After that you get the answer. How much? Now 10 to the power 6. Yes. So you have got the answer. Yes, yes, Arvind. It is understand now. 5 into 10 to the power 6 pixel. Okay, that means 1, 2, 3, 4, 5, 6. Okay. Around 50 lakhs pixel is required to cover this area. It is clear to everyone? Five into 10 to the power 6, it is the answer. Okay, 5 into 10 to the power 6. This is the answer. So go to the next question. What are common application of image segmentation in remote sensing? Select all that type. What are common application of image segmentation in remote sensing? Select all that are apply. This is the MSQ. Okay. Yes. Okay, Arvind. A and B. What are common application of image segmentation in remote sensing? A, B. Okay, anyone? Ankit? Okay, A, B. Anyone? Anyone? Those are sitting in the classes. Anyone? What are the common application? So at first see the okay image segmentation is a method that assign a unique label to each pixel in a image, enabling the identification of a regions with the similar characteristic and the delineation of boundaries between this region, specifically known as same segmentation. It distinguishes itself from instance and panotopic segmentation. So what is image classification or image segmentation? Suppose you have a image, okay, and based of the image you have a some value, okay. So in the image segmentation what happened? Now assign a unique label to each pixel in an image, okay, enabling the identification of the region with a similar characteristic. Okay, suppose we are going to uh, hmm, we are going to visit a temple, okay, visit a temple. Suppose someone have uh, wearing hair blue color, blue color, blue color, blue color, Okay, someone wearing dress in yellow color. Okay, or someone like a violet color. Okay, so what happened? Image segmentation now of the region with the similar characteristic and the delineation boundary between this region. So what happened? Now whenever what is the similar characteristic here? So we can say this is a similar boundary in this region. Okay, this is a region like a. Okay, also this is a region like a B, and this is a region like a C. Okay, so whenever we have classified a image, so what happened? We can say vegetation. Okay, then what? Building, road, water, land. Okay, so the answer is land cover classification as object recognition. Okay, this answer is wrong. Option A and B is correct. Those are given option A and B. Everyone is right. Okay, if asking what are the different steps for image segmentation, then it cover the atmospheric correction, cloud detection, land cover classification, object recognition. Okay, there is the steps, but here asking the what are the common application. Okay, because whenever we have going to a satellite image, at first we need to remove the cloud, then go to atmospheric correction, then land cover classification, then object recognition. Okay, it is clear. Then go to the next question. If a surveyor measure a distance 5 times and obtains value 10.2 meter, 10.3 meter, 10.2 meter, 10.4 meter and 10.3 meter, calculate the mean value, standard deviation and the coefficient of the variation. They are asking about calculate the mean value, standard deviation and the coefficient of variation. किस किस को पता है इसका फॉर्मूला? मीन का तो सबको आना चाहिए, मीन का फॉर्मूला क्या है? मीन का फॉर्मूला किस किस को आता है? मीन का, स्टैंडर्ड डिविएशन का, ओके, स्टैंडर्ड डिविएशन एंड कोएफिशिएंट ऑफ वेरिएशन किसको किसको आता है कैलकुलेशन करने में? You know the in the engineering mathematics section, engineering mathematics, there is a section is mean value, standard deviation and coefficient of variation. Anyone try to solve this question? Okay, mean is 10.28. Then what is the standard deviation? What is the value of standard deviation? Standard deviation equal to what? Okay, So value is here 10.2, then 10.3, 10.2, 10.4 and 10.3. So mean value is here 10.28. तो क्या करना है आपको, वैल्यू से मीन वैल्यू का डिफरेंस निकालना है हर एक वैल्यू का। ओके, तो यहाँ पे क्या हो जाएगा, डिफरेंस आ जाएगा। उस डिफरेंस को क्या करना है, स्क्वायर करना है, उसके बाद उसको समेशन करना है। ओके, तो उसका शॉर्ट फॉर्म कैसे लिखना है, स्टैंडर्ड डिविएशन इक्वल टू रूट ओवर ओके 10.3 माइनस 10.28 स्क्वायर प्लस देखो ये है मीन का इक्वेशन। ओके, एंड स्टैंडर्ड डिविएशन क्या है, इधर शायद एक बार इसको क्लीन करना पड़ेगा। एक बार मैं तुम लोग को फॉर्मूला दिखा रहा हूँ, ठीक है, तुम लोग कोशिश करना इसको सॉल्व करने का। फॉर्मूला ये है, ठीक है। स्टैंडर्ड डिविएशन मीन्स रूट ओवर जितना वैल्यू है हर वैल्यू का क्या करना है, वैल्यू माइनस जो मीन वैल्यू है उसका स्क्वायर करना है, प्लस वैल्यू माइनस मीन वैल्यू है उसको स्क्वायर करना है, डिवाइडेड n/1 मीन्स 5/1। तो इसका समेशन निकल जाएगा, उसका डिवाइडेड बाई 4 करोगे तो स्टैंडर्ड डिविएशन निकल जाएगा, ठीक है। तो कैलकुलेट करो सारे लोग। टेन पॉइंट टू माइनस 10.28 उसका स्क्वायर प्लस हाउ मच 10.3 माइनस 10.28 उसका क्या है स्क्वायर प्लस 10.2 माइनस 10 पॉइंट कितना करना है 10.28 ओके उसका स्क्वायर प्लस 10.4 माइनस 10.28 उसका स्क्वायर प्लस 10.3 माइनस 10.28 उसका स्क्वायर ओके। तो ये कितना आ जाएगा, वैल्यू 0.1016 डिवाइडेड बाई 4 ओके इक्वल टू स्टैंडर्ड डिविएशन इक्वल टू 0.0254। it is clear to everyone how to get 0254? it is clear or need to describe elaborately? it is clear to everyone or need to calculate step by step? The answer is 0.0254 okay। Arvind, it is clear now, coefficient variation okay। So basically you need to calculate root over at first how much 10.2 minus 10.28 এর whole square plus 10.3 minus 10.28 एयर होल स्क्वायर प्लस सो ऑन। ओके, एवरी 5 वैल्यू का तुम्हें ऐसे स्क्वायर रूट कर लेना है, ठीक है, डिवाइडेड बाई n माइनस 1, so each 4, so equal to 0.1016 divided by 4, so your standard deviation is 0.2544। okay, yes, root of 5 minus 1, yes, n minus 1, here n is 5, so that is n minus 1. So this is the equation. Okay, it is clear, Ankit, Sri Bhumi, Sri Brahman, Sapam, those are sitting in the class. It is clear to everyone. Then standard deviation equal to wrong. Arvind, your answer is wrong. Standard deviation equal to, now standard deviation what? 0.0254. Okay, divided by mean what? 10.28 into 100. Okay, yes, the answer is 0.247. Yes, 0.247, the coefficient of variation. Okay, the coefficient of variation is 0.247. Okay, yes, it is clear to everyone. Just remember the equation. Okay, coefficient variation equal to standard deviation by mean into 100. Standard deviation equal to x minus mean and whole square divided by n. Where is the summation of n? The summation of n minus means the value डिफरेंट बाई मीन वैल्यू उसका स्क्वायर है, ठीक है, उसका समेशन करना है हर एक वैल्यू का, तो जाके देन रूट ओवर n माइनस 1। ओके, इट इज क्लियर टू एवरीवन? इट इज क्लियर? shall I go for next question? Those are sitting in the class, shall I go for next question? अरविंद, अंकित, त्रिभुवन, तपम, shall I go for next question? प्लीज बताइए जल्दी बताइए, टाइम 9:49 हो गया। ओके, if a satellite revisits the same location every 6 days, calculate the number of images it captured in a year 2020, sorry. If a satellite revisits the same location every 6 days, calculate the number of images it captured in a year 2020. Okay, satellite revisiting same location means the temporal resolution. Okay, क्या क्लास में मजा आ रहा है सब लोग को? अगर मजा आ रहा है तो पहले यस बताइए, ठीक है? क्या क्लास में सबको मजा आ रहा है? अगर मजा आ रहा है तो बताइए, यस बताइए। क्लास कैसा लग रहा है सबको? अगर मजा आ रहा है तो यस बताइए, यस सर। अच्छा, ओनली सही तरुण और अरविंद को अच्छा लग रहा है, बाकी सबको अच्छा नहीं लग रहा है। कोई रीजन? Tapam, are you there? अच्छा, geospatial classroom, Ankit 61. Okay, there is a trick. Okay, okay, geospatial classroom. So if a satellite revisits the same location every 6 days, calculate the number of images it's captured in a year 2020. At first tell me, 2020 is a leap year or normal year? 2020 is a leap year or normal year? Anyone? 2020 is a leap year or normal year? Yes. So leap year means you need to add one more days. So 365 plus 1 divided by 6. So 366 divided by 6 equal to 61. It is clear to everyone? Those are giving answer 60. It is clear to everyone? Where is the trick? कहाँ पे क्वेश्चन घुमा गया था? 2020. So be careful. 2024, 2028, 2032. Yes, yes, Sapam, yes. So if the satellite revisit the same location every 6 days, calculate the number of images it's captured in a year. It's 61. Okay, that means the temporal resolution is 6 days. Shall I go for next question? Shall I go for next question? If a satellite revisits the same location, it is clear to everyone. Ankit, it is clear? Ankit, tell me, it is clear to you? Okay, go to next question. So here is the equation: number of images per year equal to number of days in a year by revisit interval. Okay. If a GNSS user experience error due to ionospheric delay 10 meters, multipath 5 meters and clock error 8 meters, calculate the total GNSS error. If a GNSS user experience error due to ionospheric delay 10 meters, multipath 5 meters and clock error 8 meters, calculate the total GNSS error. Those are the new in the class. Okay, every day at 9 p.m. we have conducting the live session in MCQ series. We are trying to cover most of the mathematical or NAT type question or MCQ type question. Okay, that is difficult, or we are covering all of the topic from the broad region, and those are the new in the class. We have a Android application as a name remote sensing GIS home. This is available on Play Store. Okay, or you can find the link on the different in the description box. Okay, so you may download. Okay, geospatial classroom test, Ankit test. Anyone? Those are sitting in the classroom. If a GNSS user experiences error due to ionospheric delay, Sushant Kumar. Hi Sushant Kumar, I think you the newcomer. multipath 5 meters and clock error 8 meters. Calculate the total GNSS error. The answer is 10 plus 5 plus 8 समान 23 meter. Okay. Why? Now the reason is what type of error we have observed in the GNSS receiver of GPS receiver. One is ionospheric delay, another is multipath, and another is satellite clock error. Okay, so total error equal to ionospheric plus multipath plus clock. Okay, so equal to 8 plus 5 plus 10 equal to 23. अब लोग सोच रहे इतना इजी था, कर नहीं पाया. अरे पहले आपको समझना चाहिए बेस ना. If a GNSS user your due atmosphere, calculate the total GNSS error. Okay, suppose a question asking total error is 17 meter. Okay, and multipath 7 meter. Okay, so tell me the ionospheric delay error. Total error 70 meter, multipath 7 meter. Tell me the ionospheric delay. So ionospheric delay is 17 minus 7 equal to 10 meter. Okay. If asking any section total and they are given the total value and one of the value like a multipath, then is the rest of the value. Yes. Okay. So then go to the next question. A topographic map prepared by a Survey of India covers 30 minutes by 30 minutes area on a single map. The minimum ground distance which can be represented on this map is meter, round up to 2 decimal place. A topographic maps prepared by Survey of India covers 30 minute into 30 minute area on a single map. The minimum ground distance which can be represented on this map in meter, round up to 2 decimal place. A topograph. One thing, those are the new in this classroom. Please hit the like button. Okay. So that's why I am attendance your marks. Okay, attendance your presence, and we have a Android application in our Google Play Store. So you have go to the Play Store and search remote sensing GIS home. You have find the apps also. Okay, and we have offering a 15 days crash course only for 2000 rupees. Okay, only 2000 rupees. All are okay. Thank you, Rupesh. Why 3 into 10 to the power 9 upon a topographic map prepared by Survey of India covers 30 minute by 30 minute area in a single map. The minimum ground distance which can be represented on this map is dash meter up to 2 decimal place. Do you know the SY standard, Survey of India standard? Anyone, or shall I go for calculation? Anyone trying to solve, or shall I go for the calculation? Ankit, Sapam has already given the answer. Rupesh, Sahit Arun, Geospatial classroom, those are sitting in the class. Okay. So today we have covered the number system by topographic map, that is Survey of India. Okay. So in the world, overall, initially the total area covered 4 degree into 4 degree sheet. Okay. So if you see any number like a 61, okay, 61 this area, okay, this is the 4 degree into 4 degree sheet. Like a 63, it also 4 degree by 4 degree sheet, and 45 also 4 degree by 4 degree sheet. So initially in the whole world, internationally we have prepared 4 degree into 4 degree sheet, that is called the million sheet. Okay, the scale is 1 is to 10 million, 1 is to 10 lakh. Okay, sorry, 1 is to 10 lakh. Okay, sorry, 1 is to 10 lakh, that is called the million sheet. Okay, 1 is to 10 lakh, 1 is to 10 lakh. Okay, so 4 degree equal to, whenever we have read the topo sheet, we have seen 43 j by 3, 73 8 by j. Okay, so this 4 degree equal to, that means 4 degree into 4 degree means 1 is to 10 lakh. Okay, so this is the 1 is to 10 lakh. That means on the map, 1 unit on the map represent 10 lakh on the ground. Okay, in the 4 degree into 4 degree million sheet. So suppose I am taking a million sheet, that number is 73. Okay, so that is number, suppose 73. So this is 73. Suppose I am taking this million sheet 73. Okay, so this is the 73 sheet. So what happened after that, we have divided in 16 grid. Okay, 4 degree million sheet divided in 16 grid, like a B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay, so initially this sheet is 4 degree by 4 degree. After that we have divided in the 1 degree equal to 1 degree. So this area is 1 degree. Suppose I am taking a single part, that is the A. A is 1 degree equal to 1 degree. Okay, so 0, 1, 2, 3, 4. Again 1, 2, 3, 4. So this A represented 1 degree equal to 1 degree sheet. That means 1 is to 2,50,000. Okay, 1 is to 2,50,000. 1 degree equal to 1 degree sheet represent 1 lakh, 2,50,000 second. Okay, so suppose here I am taking here J. Okay, J sheet. Okay, so now it is clear up to degree sheet. So what happened? Initially we have get 73 and J. Okay, so that means in 73 further we have divided 16 part, A, B, C, D, E, F, G, H, I, J. So this part each number is 73J or 1 degree into 1 degree set. Okay, so after 73J we have converted into 4 section. Okay, so that is 73J northeast, northwest, southeast, south west. Okay, so this is the 30 degree sheet. If someone asking 73J northeast, that means 30 minute into 30 minute sheet. Okay, so 30 minute into 30 minute sheet means how much? 1:1,25,000 feet. Okay, that means on the map 1 unit represent on the ground how much? 1,25,000 unit. Okay, so suppose this is the another part. Again go to the details part. So now 73J, how to go into 1573J. So suppose 73J we have divided in the 16 part. 73J we have divided again 16 part like this. Okay, yes, answer is 1 lakh yes, but I am going to the detailed discussion after that. Okay, so 73J again we have divided into 16 parts. 73J by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If someone tell 73J by 10, that means how much? Anyone? How much interval? 73J by 10. 73J by 10 means how much? If 73J is to 1 degree into 1 degree, so 73J by 10 is how much? Anyone? Seventy-three J by 10. It is 15 minute into 15 minute sheet. Okay, so this sheet is now 15 minute equal to 15 minute. Yes, 15 minute equal to 15 minute. 15 minute equal to 15 minute. That means 1:50,000. Okay, it is clear. It is clear now, everyone. Now go to the conclusion. Okay. It is clear to everyone. Any doubt regarding the map section? Okay. This question are asking from basics part. Okay. So 4 degree equal to 4 degree. How much? 1:10 lakh. Okay. Then 1 degree equal to 1 degree. 1:2,50,000. Okay. Then 30 minute into 30 minute. 1 is to 1,25,000. Then 15 minute equal to 15 minute, that is 1 is to 50,000. Okay, again 7 minute 30 second into 7 minute 30 second equal to 1 is to 25,000. Okay, so 73 J by 10 again can be divided by 4 part. Okay, then north east, southeast, southwest, southeast. Okay, if someone tell you 73 J by 10 northeast, that means the seat is 7 minute 30 second or 7.5 minute, that means 1 is to 25,000 scale. It is clear to everyone, those are sitting in the class? It is clear the map section, how to get the topo-sheet number? Sapam, it is clear? Ankit, everyone clear? So any doubt you can ask me. So now calculate a question. Okay, a map prepared by Survey of India, that is number 73, sorry, not 73, suppose 54 N. Okay, a map prepared by Survey of India 54 N. So to cover the 54 N, how much 15 degree, a 15 minute sheet is required to cover, suppose 54 N, how much 15 minute sheets are required? A, B, C, D, E, F, G, H, I, J, K, L, M, N. Suppose this section cover करने के लिए 15 मिनट इंटू 15 मिनट कितना सेट रिक्वायर है? ये मैप प्रिपेयर बाय सर्वे ऑफ इंडिया. ओके, 54 N. To cover this area, how much 15 minute into 15 minutes sheet is required? Suppose this sheet number is 54 N. To cover this area, how much 15 into 15 sheet is required? Anyone? So basically this sheet is how much? 1 degree equal to 1 degree. 54 is equal to 4 degree equal to 4 degree. And 54 N equal to 1 degree equal to 1 degree. एंड तो 1 डिग्री एक सीट है, उसको 15 मिनट इक्वल टू 15 मिनट कवर करने के लिए कितना सीट चाहिए? बहुत ही इजी क्वेश्चन है, बहुत ही इजी क्वेश्चन। तो सपोज दिस सीट नंबर इज 54N। ओके, इसमें मुझे कवर करना है कितना? 15 मिनट इंटू 15 मिनट। ओके, तो दिस इज 1 डिग्री 1 डिग्री सीट। ओके, 1 डिग्री सीट। वी नो 15 मिनट इक्वल टू 15 मिनट, तो 1 डिग्री इक्वल टू हाउ मच? 60 मिनट। ओके, so if I know the area of this map, 60 into 60 divided by 15 into 15, okay, (16 cities required). If I go to manually, 15 minute, 30 minute, 45 minute, 15 minutes, 30 minutes, 45 minutes, 60 minutes equal to 1 degree. Again same side also, 15, 30, 45, 60. So 4 into 4, 16 cities required. It is very easy. Now clear everyone? It is clear to everyone? Those are sitting in the classroom, it is clear to everyone? Upon 1 degree equal to, why you have write down 1.85 into 1.85? It is clear to everyone? Okay. So thank you everyone. If you any doubt regarding session, you may ask now. अगर किसी का कोई डाउट है रिगार्डिंग, if you have any doubt, any query regarding this session, you may ask. If you have any doubt, any query regarding this session, you may ask now. किसी का कोई डाउट है रिगार्डिंग दिस सेशन? Those are sitting in the class, please feedback about the class, okay, because you know your motivation encourage me to make a different type of question, okay. Please give your feedback on the YouTube box, okay. Yeah, Sai Tarun 16, Savoni 16, okay. Please give your feedback and share among your friends, junior, those are want to prepare, okay. Any doubt, any query? Sapam, Shravani, Sahitarun, Rupesh, Sri Brahman, Sushant, Geospatial classroom. Okay, thank you everyone, thank you. Everyone have understood everything? Any doubt, any query? Okay, good night everyone. You may leave the session. Good night everyone. Yes, again tomorrow at 9 p.m. we will meet. Thank you everyone. Thank you. Yes, good night everyone. Tata. See you tomorrow. So keep practice, keep watching and keep engaged with remote sensing GIS home. Thank you everyone.